Section 15B.2, question number 5, page 367. After question 4, where we were to solve for a couple of constants, a and b, we're given a little bit more of a challenging question to work on and find the constants a and b as well. We're given the function y equals a over the root of 1 plus bx, and a and b are constants. We need to find a and b given that when x equals 3, y equals 1, and when x equals 3, dy by dx equals negative 1 over 8. Okay, so we've got a few things that we can do here. So first I'm going to rewrite this as a times 1 plus bx all to the negative 1/2. So then finding the derivative will be a little bit easier. And the derivative function I'll just do up here to save a little bit of room. So the gradient function, when I differentiate, I bring the negative 1/2 down in front, so I got negative 1/2 times a multiplied by 1 plus bx, and then I subtract 1 from negative 1/2 to give me negative 3/2, and then I go on the inside here and take the derivative of that, which just gives me b. So we were given that when x equals 3, that y equals 1. So we can set y equal to 1. So when x equals 3, we know that y equals 1. So 1 equals a quantity 1 plus b quantity 3 to the negative 1/2, which can then just be written as a quantity 1 plus 3b all to the negative 1/2. And when x equals 3, the derivative was equal to 1 over 8, negative 1 over 8, sorry, as I keep misreading things. So negative 1 over 8 equals negative 1/2 a 1 plus b times 3 to the negative 3/2, and that is, actually maybe I'll stick that b in front here also, just to simplify a little bit. So then I can maybe multiply both sides by negative 2 to get rid of this negative 1/2 here. So multiply both sides by negative 2, I end up getting 1/4 equals AB, and maybe while I'm at it, I'll maybe put this down into the denominator. So I'll do 1 plus 3b all to the 3/2. And maybe while I'm at this, I'm not sure what works best, if I write this back into that form or not. I could just write that there anyways. It may not come to any usefulness, but at least it's back in the same form as is given there. And I guess we could do the same thing here. Not that that will really, I'm sure it won't do a whole lot to help us. So it would be 1 plus 3b all cubed and the square root of that. Okay, so that's just written in the same form. We'll see how things go from here. So if I've got here, I can multiply both sides by the denominator. So I can get the square root of 1 plus 3b equal to a. And then what I can do is I can perhaps square this, square both sides here. So that would be 1 plus 3b equals a squared. So that's one part that we can do. And over here, and I've got 1/4 equals AB over 1 plus 3b all cubed, the square root of that. Maybe I can multiply both sides by 4 and then multiply both sides by the square root function so we can get rid of that denominator. So I've got 1 plus 3b all to the 3/2 equals 4ab. And then, what else can we do with this? Well, we can perhaps, actually maybe I'll rewrite this a little bit lower because I think I have to use some of this over here to do a little bit of simplification. So I'm just going to write this down a little bit lower and do a little erasing up here just to provide another little step here, intermediate step. Sorry about that. So if I cube both sides, so that is actually 1 plus 3b all to the 1/2. This is as I recognize what's going on over here. I see I've got a 1 plus 3b to the 3/2, and here I've got a 1 plus 3b to the 1/2. So if I cube both sides, I get 1 plus 3b to the 3/2, and that equals a cubed. So this thing is written over here. So if this equals a cubed, then this has to equal a cubed. So I can write a cubed equals 4ab. And then I can divide both sides by a to give me a squared equals 4b, which may come in handy. And now from this line that we saw before, I've rewritten that down here after squaring both sides. So I've got 1 plus 3b equals a squared. Well, a squared from over here equals 4b, and this will now consolidate the b's, so I've got just one variable to deal with. So now I've got this equation, 1 plus 3b equals 4b, because that 4b got substituted in for this a squared. And now I just rearrange this, so I subtract 3b from both sides, so you get 1 equals b, or b equals 1. And then now we know that a squared equals 4b, we know that b equals 1, so a squared equals 4, therefore a equals 2. Therefore a equals 2 and b equals 1.